Welcome to MyProjectBazaar.com. Project title: Geographic and Opportunistic Routing for Underwater Sensor Networks. Let's see the abstract. In general, geographic routing protocols have several desirable features for use in network and the sensor networks, but are susceptible to voids and the localization errors. In this paper, we propose the GEDA routing protocol for underwater sensor networks. GEDA is a unicast geographic and opportunistic routing protocol that routes the data packets from the sensor nodes to the multiple sonobuoys at the sea surface. The simulation results show that JEDA significantly improves the network performance when compared with the baseline solutions, even in hard and the difficult mobile scenarios of very sparse and very dense networks, and for also high network traffic loads. Let's see the flow diagram. First, the network is created with the number of mobile sensor nodes and the sonobuoys. In this, the mobile sensor nodes are placed at the that is below the surface area, and the sonobuoys are placed in the surface area of water. The sensor nodes generates a beacon which is periodically generated, and to forward to the sonobuoys, it finds the next forwarder node. This forwarder node is found out by the neighbor node selection process. In this, if the forwarding process is done, the void is created or not is verified at the time. If a void is created, then it processes the recovery mode to recover the void and to forward the data packets. If not, means it straightly forwards to the sonobuoys, and then the performance evaluation is done, which is compared to the proposed system with the existing system. Now see the running procedure of our process. First, open the terminal window. Then go to the directory where we have the code, then type ms space filename.tcl. Now the coding is running, 55 nodes are created and the overall width is created. For this, the beacon size and the neighbor node positions are updated the network, and the void recovery performance is also processed. The processing in the simulation are displayed here. After running it, to see the simulation output, type nav. The network animator window opens. Go to File, Open, Out.nav. This is the underwater sensor network area. These are the sensor nodes that are placed, and these are the forwarder nodes that are selected. We can speed up the process with this icon. Here the network is formed, and then in the surface area the sonobuoys are placed. The sensor nodes under the water are generate data, and it must forward to the sonobuoys. So because of the long distance, forwarder nodes are selected in the network. These forwarder nodes collect data from these sensor nodes, and then it go to the surface area and give to the sonobuoys. The sonobuoys will further transfer to the base station. By seeing only the underwater sensor area, the sonobuoys are itself considered as the sink, and the sensor nodes with the mobility are considered as the source nodes. we can able to see that all nodes are not statically placed in one place, that is, it moves throughout the entire range of the network. The nearby nodes are easily given to the sonobuoys, but the farthest nodes that do not able to give to the sonobuoys are give data to the forwarders, and the forwarders will collect information from these mobile sensor nodes and it give to the sonobuoys. After running the simulation, we see the performance result in graph. For that, back to the terminal window and type graph name.plot. This is the total number of control factors that's generated during the simulation time. So at the various simulation time, the control packets are calculated. The existing system have high, but the proposed system have less. To see another graph, Readme plot graph name.plot. Here the delay is calculated for the simulation time. Like we see that the existing system has a higher delay, but in our proposed system, the simulation time is varied and calculated the delay which is less than the existing system. Thus, the overall performance of the network is increased.